Okay, so in this video, let's understand what confusion matrix is and how it helps us overcome the problems with accuracy. So let's say I have binary classification problem. Okay, that means that I have only classification. That means that I have only two classes in my data set, 0 and 1. Okay, and I'll draw a matrix like this. Okay, it's classified into two parts, 0 and 1. So over here, I take all the actual values, okay? And over here, I take all the predicted values. What are actual and predicted values? So if I have x1, x2, x3, all the way to xn, and I have the class labels as y1, y2, y3, all the way to yn, then these class labels are the actual values. And when the model works on this data set, right, and it predicts some class for the data point, let's say those points that let's say those predicted classes are y1 hat, y2 hat, y3 hat, all the way to yn hat. Okay, so these are the predicted values. Okay, so let's say I have 0 0 and 1 over here. So that means that if my actual value was 0, how many of those values were correctly predicted as 0? And if my actual value was 0, how many of those were incorrectly predicted as 1? Similarly, if I have 1 over here, if my actual class label was 1, how many of them were incorrectly predicted as 0? And if I have 1, how many of them were correctly predicted as 1? Okay, those number of points will come in this. So here are some terminologies that I want to um, tell. All the points in this 0 0 column, right? Uh, they're called true negatives. All the points here are called false negatives. All the points here are called false positives, and all the points here are called true positives. Okay, let's say this is column A, this is column B, this is column C, and this is column D, right? So what are true negatives? True negatives are negative is basically the negative class, okay? 0, that's the class. And true negative is all the negative classes that were correctly classified. That's where the true comes from. Similarly, what is false negative? Negative is the class that was predicted, which is 0 over here. And false comes from the fact that it was incorrectly predicted. False positive is the predicted class over here is 1, and 1 over here is my positive class. So false positive is basically the positive classes that were predicted, or the classes that were predicted as positives, but they were falsely predicted. Similarly, true positives are all the classes that were predicted as 1, which are because it's positive, right? This is my positive class, and this is my negative class. 0 is my negative class, 1 is my positive class. So this is true positive. Okay, so ideally you would want your A and D to be high. Okay, because we are concerned with all the positive or negative data points being correctly classified. And you would ideally want your B and C's, which is this column and this column, to be low. Because we want to minimize the incorrectly predicted classes, no matter where they come from, 0 or 1. We want to minimize the classes that were incorrectly predicted, right? So let me just give you a few basic terminologies here. There's something called a true positive rate, which is true positive upon the total number of positives. So what is the total number of positives? So all the values in these columns are the negative values, okay? And all the values in this column are the positive values, okay? So true positive rate is basically true positive upon the total number of positives, okay? Which is equal to D upon B plus D, right? Because this is B and this is D, and true positive upon positive. So that's D upon B plus D. Then you have something called, just bring the square down there, the matrix. You have true negative rate, which is, as you might have guessed, true negative by the total number of negatives, which is basically A upon A plus C. Then you have the false positive rate. Okay, this is false positive whole upon or the total number of negatives, which is basically C upon A plus C. And then you have the false negative rate, which is equal to false negative upon positive, which is equal to false negative is B upon B plus D. Okay, so ideally you would want this to be high and you would want this to be high. Okay, because you want all the true values to be high, right? True negatives and true positives. And we would want this to be low and we would want this to be low. So let's see how this actually helps us overcome the problems that we saw in accuracy, right? Let's say I have a very highly imbalanced data set. For example, my data set is, let's call it dn, and it has 900 negative points and it has 100 positive points. Okay, and let's just say that out of these 900 negative points, 850 were classified correctly, were correctly classified as negative, and 50 were incorrectly classified as positive. Incorrectly classified as positives. Okay, similarly, let's say I have 100 data points here, out of which 94 were classified correctly. This is correct, right? And 6 were classified incorrectly. Okay, now if I have a dumb model, I can just say that all the points are negative. I'll still get a 90% accuracy, right? But if I draw a confusion matrix, right? Let me just redraw this. It didn't come out very well. If I have a confusion matrix, and again, I'm just taking the same convention I used over there. This is 0, this is 1, this is 0, this is 1. And this is true negatives, right? So this is 850. This is true positives. This is 94. This is false negatives, which is, sorry, this is false. I'm getting confused myself. This is false positive, and which is 50, right? Because it was incorrectly classified as the positive class. And this is 6. Okay, so if I just take something like accuracy over here, and my dumb model can just give me 900 by 1000, which is a 90% accuracy. But over here, I have a good idea about what class is what. Here again, this is 100 because this falls in there are 100 positive classes, and this is 900 because there are 900 negative classes, right? So using TPR and TNR, I have a good idea about what is the actual positivity and the negativity rate, which is 94 upon 100 and 850 upon 900, right? So this is how a confusion matrix can help you overcome the problems of accuracy, because even in an imbalanced data set, these 4 rates, TPR, TNR, FPR, and FNR, can help us understand how the model is performing even in an imbalanced data set. Right, so I'll stop the video here and I'll see you in the next video.